Hot Soap vmodTFT by Popa Ștefan, Transylvania University, Brașov, Romania. My name is Popa Ștefan and I'm student at Transylvania University, Faculty of Electrical Engineering and Computer Science, specialization Applied Electronics, in the second year. My project goal is to create a hot swap interface for the vmodTFT module. I use the following hardware: Atlas FPGA Xilinx Spartan 6 and the vmodTFT screen. The objective of the project are: when the users connect the vmodTFT to the board, the software that runs on the board detects the screen and starts sending data. The data is the frames of a movie, sequence of linked images. If the vmodTFT is disconnected from the board and reconnected after some time, it will start the transmission at the exact same frame when it was disconnected. Hardware architecture. Let's do a presentation of the hardware architecture using the block diagram from Xilinx. We have the microblaze microprocessor, which is connected to the BLB bus. We have the DDR2 memory, where the program and all the instructions are stored. We have the controller for the vmodTFT screen and the clock generator. Let's continue with the software architecture. The first step was to develop a program that shows an image on the screen. The image was encoded with another program written in C++ that has a PMP image as input and a vector of numbers as output. Each number is the output in the output vector symbolizes a pixel, 6-bit for a RGB pixel. Using the vectors of the frames, the board software shows the images on the vmodTFT. The next step is to detect when the screen is connected or disconnected to the board using the break signal of the vmodTFT, which is penir Q, and the pressure of the touch referred to as the Z coordinate. Finally, the software will remember the frame at which the screen was disconnected. Let's see a demo of the software that encodes the BMP image into a vector of numbers. For example, we take this image, which is a BMP image with basic colors, and we want to obtain the vector. We start the program. We insert the name of the image. The program shows all the information of the image, and when it finishes, the output will be in a text file, out.txt file. You can see here the output of the image, and we copy this vector of numbers and we paste it into the source code of the software that runs on the board, on the FPGA board. For example, here we have a movie of about 9 frames, and each frame is stored in the program as a vector of int, and here is the code for the succession and for the succession of images and the program that shows these images on the TFT module. Thank you for your attention.